Hello, my name is Daniel, and today we will be going through the AMC 12B from the year 2004. So let's get started. First problem. At each basketball practice last week, Jenny made twice as many free throws as she made at the previous practice. At her fifth practice, she made 48 free throws. How many free throws did she make at the first practice? Okay, so let's call the number of free throws she made at the first practice. This would be X, right? So if the first number of throws she made is X, then her fifth, this would be X times 2 to the fourth power, so that would just be 16X, right? And this is equal to 48. So X is equal to 48 over 16, which is 3. So the answer is 3, it's A. Number 2, in the expression, this one, the values of A, B, C, D are 0, 1, 2, and 3, although not necessarily in that order. What is the maximum possible value of the result? So since for D, since we are subtracting a value, it will be maximum if that was 0, so D would be 0. C times A to the bth power, that would just be something times something if 1 is in B, and it would just be just one thing if A was 1, so C must be 1, and of those A and B, of 2 and 3, and 3 to the second power, this is 8 and this is 9, so this is bigger, so the maximum is 9, which is D. Number 3, if x and y are positive integers for which this is 1296, what is the value of x plus y? Okay, so for this one, we just have to dissect 1296, so we just have to prime factorize it. 1296, this is divided into, we can say 4, right? And then that would give us 324, and then we can do it 4 again. That would give us 81. Okay, so we can see that this one gives us 2 to the fourth power, and this gives us 3 to the fourth power. So this is x and this is y, so x plus y, so x is 4 and y is 4, so x plus y equals 4 plus 4, which is 8, right? So the answer is 8, it's A. Number 4, an integer x with x is between 10 and 99 is to be chosen. If all choices are equally likely, what is the probability that at least one digit of x is a 7? Yes, so we have total of 90 possibilities, right? So that would all be over 90. And for at least one digit of x to be a 7, we can just have the numbers from 70 up to 79. And plus we can have the numbers from 17 up to 97, right? But then 77 overlaps, so we just have to take out 77. So this would be equal to all over 90, and then this would be 10 numbers, this would be 9 numbers, and this would be 1 number, right? So this is 18 over 90, which is equal to 1 over 5, right? So this is the answer, it's B. Number 5, on a trip from the US to Canada, Isabella took D US dollars. At the border, she exchanged them all, receiving 10 Canadian dollars for every 7 US dollars. After spending 60 Canadian dollars, she had D Canadian dollars left. What is the sum of the digits of D? Okay, so first Isabella had D US dollars, and then this became 10 over 7 D Canadian dollars, right? And then she spent 60, and then she had D left, so 10 over 7 D minus 60 equals D Canadian dollars, right? And so if D goes over there, then that would give us that 3 over 7 D equals 60. So D equals 60. Yeah, so D equals 60 times 7 over 3, which is 140, right? So this is the D, so we want the sum of the digits of D. So that will give us 1 plus 4 plus 0, which would equal 5, right? So the answer is 5. It's A. Number 6, Minneapolis to St. Paul International Airport is 8 miles southwest of downtown St. Paul and 10 miles southeast of downtown Minneapolis. Which of the following is closest to the number of miles between downtown St. Paul and downtown Minneapolis? Okay, so if it's 8 miles southwest of downtown St. Paul, then if we have St. Paul right here, then it will be 8 miles southwest, right? So about this much. So this would be 8 miles. And then if we have like a flat thing, yeah, so if we have a flat line, then this would be 45 degrees, right? Because it's like exactly southwest, right? And then it's 10 miles southeast of downtown Minneapolis, then this length, that would have to be 10 miles, right? So this would be Minneapolis, and this would be 10 miles, right? And then this would also be 45 degrees because that is exactly southeast. And so what that gives us is that this angle is a right angle. So if we just connect these, so if we just connect Minneapolis and St. Paul, this will be 10, this will be 8, and so this length will be, due to the Pythagorean theorem, square root of 10 squared plus 8 squared which is root 164, and then this is very, very similar to root 169, which is, yeah, root 169, which is 13. So 13 is the closest, it's A. Number 7, a square has sides of length 10 and a circle centered at one of its vertices has a radius 10. What is the area of the union of the regions enclosed by the square and the circle? So if we just draw this out, we will have something like this, right? So this will be length 10 and length 10, right? And then this would have radius of 10, right? So the square plus the circle would be this much, so the square, plus 3/4 of a circle, right? Plus 3/4 of a circle. So this is going to be equal to 10 squared, which is for the square, and then plus we're going to have 3/4 times 10 squared pi, and this is for this much, right? So this is all going to equal 100 plus 75 pi, and this is the answer. So the answer is B. Number 8, a grocer makes a display of cans in which the top row has 1 can and each lower row has 2 more cans than the row above it. If the display contains 100 cans, how many rows does it contain? Okay, so cans are, we have 1, 3, 5, 7, 9, all the way to, if we have n rows, then we would have until 2n plus 1 cans, right? And their sum has to be 100. We know that the sum of odd numbers, so the sum of consecutive odd numbers is n squared. So the sum is n squared, and the sum is 100. So this is equal to 100. So that means n is equal to 10. There are 10 rows. It's D. Number 9, the point -3, 2 is rotated 90 degrees clockwise around the origin to point B. Point B is then reflected over the line x equals y to point C. What are the coordinates of C? Okay, so we have a coordinate plane like that and like that, right? And then let's have point -3, 2. That point will be -3, 2, so that will be this point, right? And then if it's rotated 90 degrees clockwise, it will be like that, and that will go to, yeah, that will go to 2, 3, right? Like this. So that will be 2, 3, like that. And then this is point B, right? This is A. No, that's not A, that's just point B. So this is point B, and then B is then reflected over the line x equals y. Okay, so let's just draw the line x equals y. This will be that, this will be the line, and so if we have something like this, then point C, that would be over here, right? Because that's reflected over x equals y. So this is C, which is 3, 2. 3, 2. The answer is E. Number 10, an annulus is the region between two concentric circles. The concentric circles in the figure have radii B and C, with B is greater than C. Let OX be a radius of the larger circle, let XZ be tangent to the smaller circle as Z, and let OY be the radius of the larger circle that contains Z. Let A equal XZ, D equal YZ, and E equal XY. What is the area of the annulus? Okay, so for the area of the annulus, then we want the area of the so we want the area of the big circle minus the area of this small circle, right? So this much is the area that we want. So that would be just this much is B. So that would be B squared pi minus this much is C, so C squared pi, right? This is pi times B squared minus C squared. But then if we look, this is a right triangle, right? So that will give us, so this triangle will give us that A squared equals B squared minus C squared, right? Because this is a right triangle. And so B squared minus C squared is equal to A squared. So this is equal to pi times A squared. So this is A squared pi. So this is the answer. The answer is A. Problem number 11. All the students in an algebra class took a 100-point test. 5 students scored 100. Each student scored at least 60, and the mean score was 76. What is the smallest possible number of students in the class? So let's say this is n students. Right? Since each student scored at least 60, right? That means that the number of students wouldn't matter even if we just subtracted 60 from every score, right? So let's say that they took a 40-point test, and so 5 students scored 40, and the mean score was 16, right? So if there are n students, then the total sum is 16n, right? So it's 16n. This equals 5 students got 40, so that's 5 times 40, plus points that the people scored on the test, and this isn't relevant. So 5 times 40, this is 200, right? So this is just smallest value of n, that 16n is greater than 200. Yeah, is greater than or equal to 200, right? And so if we look for that, n is greater than or equal to 200 divided by 16, this is 13 point something something. And so if you see 13 times 16 equals 208, right? And so 208, this is definitely greater than or equal to 200, right? And so this is our number, n equals 13. The answer is D. Number 12, in the sequence 2001, 2002, 2003, all the way, each term after the third is found by subtracting the previous term from the sum of the two terms that precede the term. For example, the fourth term is this, right? What is the 2004th term in the sequence? Since this is all has 2000, we can just subtract 2000 from everything. So subtract 2000 from everything. This would give us values of 1, 2, 3, 0, and then 2 plus 3 minus 0, that would be 5, and then 3 plus 0 minus 5, that would be negative 2, 0 plus 5 minus 2, 0 plus 5 minus negative 2, that would be 7, and then we have negative 4, 9, negative 6, and so on, right? We have 1, 3, 5, 7, 9, and so on. This is the odd numbers, right? And for the even numbers, we have 2, 0, negative 2, negative 4, negative 6, and so on, right? And so this is just, we subtract 2 each time, right? And so if we generalize this for the nth number, for the nth number, then the value would be 4 minus n, right? This is when n is a even number. So for the nth number, it's 4 minus n. So we want the 2004th term, and 2004 is an even number, right? So we do 4 minus 2004, and this would equal negative 2000, right? So we have our value of negative 2000, but we said that we would subtract 2000 from all, so to get the actual term, we have to add 2000 to it again, right? So we have to add 2000, and that gives us 0, right? So the 2004th term is 0. That's the answer. It's C. Number 13, if fx equals ax plus b and f inverse x is bx plus a with a and b is real, what is the value of ax plus b? Okay, so let's actually try to get the inverse of fx. So f inverse of x, inverse of x, this is going to be equal to x, so this is going to be x equals ay plus b, right? So x minus b equals ay, y equals x minus b over a, right? So this is a over x minus b over a. Sorry, that's x over a minus b over a, and this is equal to bx plus a, right? And so 1 over a is equal to b, and negative b over a is equal to a, right? And so from this, we can substitute that into there. So a is going to be equal to negative 1 over a squared, right? So negative 1 is equal to 1 over a cubed, and so a is equal to negative 1, right? And if a is equal to negative 1, b is 1 over a, so b is going to be equal to 1 over negative 1, which is just negative 1, right? So a is negative 1 and b is negative 1, so a plus b, this is going to be negative 2, so that's the answer. It's A. Number 14, in triangle ABC, AB equals 13, AC equals 5, and BC equals 12. Points M and N lie on AC and BC respectively, with CM equals CN equals 4. Points J and K are on AB so that MJ and NK are perpendicular to AB. What is the area of pentagon CMJKN? Okay, so for the area of CMJKN, for this area, right, then what we can do is we can get the total area of ABC, and then we can subtract BKN, and we can subtract AJM, right? And so first, let's try to get the whole area of ABC. Since this is 5 and this is 12, that means that the total area of ABC, this equals half times 5 times 12, which is 30, right? And then it said that CN equals 4, so this is 4 and this is 4. Therefore, BN is going to be equal to 8, and AM is going to be equal to 1, right? And also, since ABC and NBK, they are similar because they both share this angle, and they are both right triangles, right? And so ABC and BKN are similar. ABC, that, and this small triangle of AJM, though they are also similar, right? Because they both share this angle, and they are also right triangles. This is right angle, and this is a right angle, right? And so ABC, BKN, and AMJ, they are all similar triangles, right? And then next, what we have to do is we have to get to the length of AB, right? Because that will let us determine the ratio of the lengths with these similar triangles, right? So since this is 5 and this is 12, by Pythagorean triple, we have this equals 13, right? So that would equal 13. 13 equals the whole of A and B, right? And so ABC to BK and to AMJ, the ratio, let's make this ratio now. ABC to BKN to AMJ. Since ABC has 13 as a hypotenuse, and BKN has 8 as hypotenuse, so this would be 13 to 8. And then AMJ has 1 as a hypotenuse, so this would be 13 to 8 to 1, right? And this is for the length. But then what we want is the area of pentagon, so let's make this the area, right? So if that's area, then we have 13 squared, which is 169, and then we have 8 squared, which is 64, and then we have 1 squared, which is just 1. CMJKN, this is ABC's area, and then we have just the total area 1 minus BKN's area, which is 64 over 169, so 64 over 169 minus, and then AMJ's area, which is 1 over 169 of ABC, right? And since ABC equals 30, that will just be 30, right? 30 times this much. So this is going to be equal to 30 times 104 over 169, and this is going to be equal to 30 times 8 over 13, which is 240 over 13. So it's 240 over 13, and the answer is D. Number 15, the 2 digits in Jack's age are the same as the digits in Bill's age, but in reverse order. In 5 years, Jack will be twice as old as Bill will be then. What is the difference in their current ages? Okay, so let's say that Jack's age is AB. So Jack's age is 10A plus B, and Bill's age will be 10B plus A, right? Because the digits are in reverse order. And since in 5 years Jack will be twice as old as Bill will be then, that means that Jack's age is greater than Bill's age. And since A and B, these are digits, that means they are single digits, right? So A and B are single digits. And so since in 5 years Jack will be twice as old as Bill will be, so 10A plus B plus 5 will be equal to 2 times 10B plus A plus 5, right? And so this is just going to be equal to 20B. Yeah, that's just going to be equal to 20B plus 2A plus 10, right? And so if we make them all go this way, then that's going to be 8A minus 19B, and this is going to be 5 is going to go there. That's going to be 5, right? And so since A and B are single digits, right? To make A single digit, then B must be 1, right? Yeah, so B must be 1. B must be 1. Because then 8A will be equal to 19 times 5, which is 24. So A is going to be equal to 3. And so their ages are 31 and 13. And it asked what is the difference in their current ages. So 31 minus 13, this is 18. So this is the answer. It's B. Number 16, a function f is defined by fz is iz bar, where I equals the root of -1 and z bar is the complex conjugate of z. How many values of z satisfy both the magnitude of z is equal to 5 and f of z is z? Okay, so let's say z equals a plus bi, right? So if z equals a plus bi, then since the absolute value of z is equal to 5, that means the root of a squared plus b squared is going to be 5. So a squared plus b squared, this is going to equal 25, right? And then since f of z has to equal z, then I times the complex conjugate of z, which is a minus bi, this is going to be equal to a plus bi, right? But then this is going to be equal to b plus ai. So this is just saying that b plus ai is equal to a plus bi, right? And so since these parts have to be the same, since these parts have to be equal and these parts have to be equal, then this just gives us that a equals b, right? And a equals b, but a squared plus b squared equals 25. So this gives us that 2a squared equals 25. And so that means a squared equals 25 over 2. A equals 5 root 2 over 2, right? And so how many values of z satisfy these things, yeah, since a squared equals 25 over 2, a is equal to plus or minus 5 over root 2, right? And so since this is plus or minus, we have two values of a, so two values, right? And so 2 is the answer. It's C. Number 17, for some real numbers a and b, the equation, this one, has 3 distinct positive roots. If the sum of the base 2 logarithms of the roots is 5, what is the value of a? Okay, so since the sum of the base 2 logs of the root is 5, that means log of 2 of m plus log of 2 of n. This is equal to 5, right? So this means that log of 2 of mn is equal to 5. That means mn is equal to 2 to the 5th power, which is 32, right? And so this this is when m and n are the roots, right? And so this means that the product of the roots are 32, right? But then since from here we can see the product of the roots, so the product of the roots is 1, that's minus a over 8. This is the product of the roots, which is 32. So this equals 32. So a is equal to negative 256. So this is the answer. It's A. Number 18, points A and B are on the parabola y equals 4x squared plus 7x minus 1, and the origin is the midpoint of AB. What is the length of AB? Okay, so let's say that A is A comma B, and B is negative A comma negative B, right? Whether A or B are plus or minus, they don't really matter, right? And then since they're both on this parabola, we can just plug them into there. So that will give us for a, b equals 4a squared minus 7a, plus 7a minus 1, right? And then for this one, minus b would equal 4a squared minus 7a minus 1. And so if you add them up, then that will give us 0 equals 8a squared minus 2. So a squared equals 1 over 4. And so a equals 1/2. And b would equal, if we put 1/2 into here, that would give us 1 minus 1. So that would go away. So that's just 7 over 2, right? So a is 1/2 and b is 7 over 2. Just be plus or minus, but the signs don't matter. So let's just not care about them and see it's all positive. And so we want the length of AB. And the length of AB, this is equal to 2 times the length of the origin to AB, right? And then this length is going to be, and this much is going to be 1/2 squared plus 7 over 2 squared, and it's all over that, right? So it's root over that, which is root over 49 plus 1 over 4. This is equal to root of 50 over 4. This is 5 root 2 over 2, right? And so we have to multiply 2 to that. And so our final answer is 2 times this much, which is 5 root 2 over 2. This is equal to 5 root 2, right? So the answer is 5 root 2, which is E. Number 19, a truncated cone has horizontal bases with radii 18 and 2. A sphere is tangent to the top, bottom, and lateral surface of the truncated cone. What is the radius of the sphere? Okay, so if we draw this out in a diagram, it will look something like this, right? So this will be the truncated cone with the sphere inside it. And so since it has radii 18 and 2, so the bases radii are 18 and 2, so that means that this much, that much is 2, and this base radii, this is going to be 18, right? And so if we draw a line from top to bottom like that, then this will give us 2 times the radius. So let's say the radius is r, then we will have 2r, right? And so yes, and if we draw one more line from the center to this line, then this will also be r. And if we draw lines like this, then we can now see that that this triangle and this triangle, they are congruent. So this line must be equal to this line, right? So that line is also 18. This much is 18. And same thing for here and here. These two triangles are congruent, right? Because they're both right triangles. So that means this length must be equal to this length, which is 2. So by the same reason, this is 2. And so that gives us that the whole of the side length, so the whole of this is 2 plus 18, which is 20, right? So that's 20. And now we can just move this line up over here, right? So we can move that over there, and we can just have this line, and we can just have this line to make one more right triangle like this, right? and then we know that this is 20, and since we know that this is 18 and this is 2, that means this distance is 18 minus 2, so this will be 18 minus 2, which is 16, right? This is 16. So we have a right triangle with this is 20 and this is the base, which is 16, and this is 2r, right? So that's 2r. And so if we divide by 2 of everything, that will just become 10, 8, and r, right? So here we can just use the Pythagorean theorem. R equals root of 10 squared minus 8 squared, which is 6, right? So the answer is 6. It's A. Number 20. Each face of a cube is painted either red or blue, each with probability 1/2. The color of each face is determined independently. What is the probability that the painted cube can be placed on a horizontal surface so that the 4 vertical faces are all the same color? Okay, so so the cube will look something like this, right? And it has 6 faces, right? And so for vertical faces to be all the same color, that means all 6 faces have to be the same color, or 5 faces have to be the same color, or 4 faces have to be the same color. But those 4 faces must be in a configuration like this, and this, right? These four side faces, right? So that's when 4 faces are the same. And so if we look at the time when 6 faces are the same, the face is either red or blue. So we have just two choices for will the whole thing be red or will the whole thing be blue, right? And for 5 faces to be the same, we first have to choose which face will be the different face, so that's 6 choices, times will the different face have red or blue color, so that's 2 times, and the rest of the faces, that will just have the opposite color, right? So this is just 12. And for 4 faces to be the same, first we need to choose which pair of faces will be excluded, right? So which pair of faces will be different, and so we have 3 choices for that, right? So we have 3 choices of pairs of faces, and then multiply by 2 because to decide which color will the 2 faces be, right? And so which color 2 faces be is chosen, then that automatically decides which color the 4 faces will be. So this is just 6, right? And so if we add these all together, then we have a total of 20 possibilities, right? But then since we have 6 faces, right, with each probability being half, that means total possibilities, they are 2 to the 6th power, right? And so what we have to do is 20 over this one, 2 to the 6th power, which is, if we divide by 4, that's just 5 over 16, right? So 5 over 16 is the answer. It's B. Number 21. The graph of this one is an ellipse in the first quadrant of the xy plane. Let A and B be the maximum and minimum values of y over x over all points x, y on the ellipse. What is the value of A plus B? Okay, so if we draw a diagram of this, then this is what we will get. Something like this, right? So that will be our ellipse. These are going to be the lines. Since A and B are the maximum and minimum values of y over x over all points x, y, since it has to be the maximum and minimum, then A and B, so A and B will be the slopes of the tangent lines. Y equals mx, right? Because they all intersect 0, 0, and their slopes can be just set as n. So here, m's roots are A and B. And so for this one, if we just substitute this into this equation, then that would just give us 2x squared plus mx squared plus 3m squared x squared minus 11x minus 20mx plus 40. This is going to be equal to, if we just add up all the factors of x squared and x and 1, right? So that will be just 2 plus m plus 3m squared of x squared plus, and then minus 11 minus 20m of x plus 40. Tangent lines, right? So they have one intersection point. So that means that b squared minus 4ac, which is the determinant, this is going to be equal to 0, right? Because the determinant is equal to 0. And so if we do b squared minus 4ac, then that will give us that it's negative 11 minus 20m squared minus 4 times 2 plus m plus 3m squared times 40. This is going to be equal to 0, and 4 times 40, that's just going to be 160, so that's 160. That's 160 times 2 plus m plus 3m squared, right? And so if we expand everything, then that will give us that 400m squared plus 440m plus 121 minus 320 minus 160m, and then minus 480m squared. This is equal to 0, and so that will give us that minus 80 of m. Yeah, so minus 80m squared plus 280m minus 199 equals 0. And so we want the sum of a plus b, and a plus b are the roots of m. So we can just get a plus m if we just get the sum of the roots of this, right? So sum of the roots is going to be negative, and then 280 over negative 80, so these cancel, and then we will factor these out. So this is going to be equal to 7 over 2, so the answer is 7 over 2, it's C. Number 22, the square of this one is a multiplicative magic square. That is, the product of the numbers in each row, column, and diagonal is the same. If all the entries are positive integers, what is the sum of the possible values of G? Okay, so first, since we have these two values, we use the fact that their multiplications are all the same, right? So that will give us that 100e, this equals this one, so BHE equals CGE equals DFE, right? And so if we try to make everything as a factor of b, right, then that will give us H equals 100 over b. Yeah, so H equals 100 over b, G equals 100 over c, and F is going to equal 100 over d, right? So that's for these green lines. And then next is, let's look at these two. 50 times, yeah, so let's look at these two. 50 times b times c equals c times f times 2. That basically means that 50 times b equals 2 times f, right? 50b equals 2f, right? So if we make 2 go over, that means f is going to be equal to 25b, right? And then since f is equal to 100 over d, that means 100 over d equals 25b, and so d is going to be equal to 100 over 25b, which is equal to 4 over b, right? So this is d, so we have d equals 4 over b, and f equals 25b, and h equals 100 over b from there, right? And then next, we can look at these two, right? 50BC and GH2, right? So 50BC is going to be equal to GH, it's going to be equal to 2GH, right? 2GH, H is 100 over B, so 2 times 100 over B, and G is equal to 100 over C, so it's times 100 over C. We get that if we do 50, this is going to be 2, and so C squared is going to be equal to 400 over B, right? So 400 over B squared, and since they all have to be positive, that means C is going to be equal to 20 over B, and G is equal to 100 over C. G is going to be equal to 5B, right? So we have C is equal to 20 over B, and G is equal to 5B. And then lastly, if we look at these two values, if you can't see them clearly, it's 50DG and BEH, right? So it's 50DG, 50 times D times G equals B times E times H, right? But then we know D, G, and H values, so this can be just rewritten as 50 times 4 over B times G, which is 5B, is equal to B times E times H, which is 100 over B, right? And so these B's cancel, so that gives us 1000 equals 100E, so E is equal to 10, right? And so now if we just draw this magic square again, then so we have everything that we need. B is up here at first, and then this is 50, and this is 2, right? And then we have C equals 20 over B, so it's 20 over B, and then we have E equals 10, and then D equals 4 over B, and then F equals 25B, and then G equals 5B, and then H equals 100 over B, right? So this is our new magic square. And then we want all the entries to be positive integers, right? And so for all the entries to be positive integers, this must be an integer, this must be an integer, and this must be an integer, right? And so that way, b must be a factor of 4, right? So that means b is equal to 1, 2, or 4. And if b is 1, 2, or 4, then that means 5b. That means 5b is equal to 5, 10, or 20, and this is g, right? So we want the sum of the possible values of g. So 5 plus 10 plus 20 is going to be equal to 35. So 35 is the answer. It's C. Number 23. The polynomial x cubed minus 2004x squared plus mx plus n has integer coefficients and 3 distinct positive zeros. Exactly one of these is an integer and it is the sum of the other two. How many values of n are possible? Okay, so since it said that one of these is an integer and is the sum of the other two, then that means that since the sum of all the roots, this is 2004, right? And that means one of the root, this is going to be equal to 2004 divided by 2, right? Because 1 is the sum of the other two, so this is going to be 1002, right? And so let's just say that the other roots, so let's say that the roots, they are 1002, and then the other two will just say it's a and b, right? And these should be not integers, and these should not be integers. And so now if we take these and if we make an equation out of them, so that would mean this is just equal to x minus 1002 and x minus a times x minus b, right? And so this is equal to x minus 1002 times x squared minus a plus b x plus ab, right? But then since 1002 is the sum of a and b, that means a plus b is equal to 1002, so this should be 1002. Here we can see that the number of a, b's we get is equal to the number of n's, right? So this is equal to the answer, right? So we want the number of a, b's that are possible. If we get that, we would get our answer, right? And so now we have this one, and with this we can use the quadratic formula. Right? So for this one, x would be equal to this divided by 2, so 501, and then plus or minus square root of 501 squared minus ab, right? Minus ab, which is 1 times 1, minus 1 times ab. So, sorry, that's minus ab. And so this would be our x values. And so now if we focus on this value, 501 squared minus AB, right, then 501 squared minus AB, this is going to be greater than 1, right, because this is inside a square root, so of course it has to be greater than 0, and this is going to be less than 501 squared, because AB is obviously greater than 0, right? And so since it's between these two values and 501 squared, that can be expanded to be 251001, right? Then just this itself, this gives 251001 minus 1, which is the 0 value. So this is 251000. So that's 251,000 values, right? But then we have to subtract some things from here, because obviously x cannot be, so a and b cannot be integers, right? So 501, so also 501 squared minus ab, so the square root of that must not be an integer. So 501 squared minus ab must be a perfect square. And so this is an integer when 501 squared minus ab, this is equal to 1 squared, 2 squared, 3 squared, 4 squared, 3 squared, 4 squared, all the way up to 500 squared, right? So this is 500 values, right? And so from 251,000 values, we have to subtract 500 values. So our total answer will be 251,000 minus 500 equals 250,500, right? So this is our answer. The answer is C. Number 24. In triangle ABC, AB equals BC and BD is an altitude. Point E is on the extension of AC such that BE equals 10, and the values of tangent CBE, tangent DBE, and tangent ABE form a geometric progression, and the values of cotangent DBE, cotangent CBE, cotangent DBC, they form an arithmetic progression. What is the area of triangle ABC? Okay, so first of all, let's label some angles. This would be B. Let's say this is B, and let's say this angle is A, right? This angle, this would be angle A minus B, and the whole thing would be angle A plus B, right? The whole thing would have an angle of A plus B, right? And so now let's first focus on these ones: tangent CBE, tangent DBE, and tangent ABE, right? So if we write them out, tangent CBE, tangent DBE, and tangent ABE, right? But then CBE, let's find CBE, that is CBE, so it's this much, which is A minus B, right? So that is, this is tangent of A minus B, and then tangent DBE, DBE is this much, right? So DB is this much, which is just A, so that's tangent A. And tangent ABE, that is ABE, so that's A plus B, right? So that's tangent of A plus B, right? This tangent A minus B, this is going to be equal to, let's zoom in here, that's going to be tangent A minus tangent B over 1 plus tangent A times tangent B, right? And we're going to have tangent A just the same, tangent A just the same, right? And then we're going to have this one, that will be tangent A plus tangent B over 1 minus tangent A tangent B, right? And so if we see, it's that it forms a geometric progression, and so that means this value squared is equal to this value times this value, right? And so tangent A squared is going to be equal to this value, right? So tangent A minus tangent B over 1 plus tangent A tangent B, right? This times, and then we're going to have this value, which is tangent A plus tangent B over 1 minus tangent A tangent B. And so if we look at these and these separately, then this would, and so that would just be equal to, so this would just be equal to the numerator, that's going to be tangent A squared. So that's just going to be tangent squared A, minus tangent B squared over, and then this is, and then the denominator, that's going to be 1 squared, which is just 1, minus tangent squared A tangent squared B, right? Because that's tangent A tangent B, the whole thing squared, right? And so this is equal to this, right? And so now we can just make this go up there, and so that will give us that tangent squared A, so these two, that will give us tangent squared A, and then minus, then this times this, so we have 4 tangent, so we have 2 tangent squared A's, so minus tangent to the 4th power of A times tangent squared B. This is going to be equal to this much, which is tangent squared A minus tangent squared B, right? And so tangent A and tangent squared A and tangent squared A are going to be cancelled, and then this plus, and then these minus are just going to be plus, and tangent squared B, they are also going to be cancelled, right? So this gives us that tangent to the 4th power of A is equal to 1. That means tangent A is, that means tangent A is 1, and that means that A is equal to pi over 4. So A is equal to pi over 4. So A, this is equal to pi over 4. The problem said that BE equals 10, right? BE equals 10, and BE is this much. But then we just found out this angle, right? And so now we can look at this right triangle. And so since this much is 10, this is 10, and this is a pi over 4, which is 45 degrees. That means, this is 45 degrees. And then this would be 10, so that's, what is it? That's BD. This is going to be 10 times 1 over root 2. So it's 1 over root 2, so this is 5 root 2, right? So BD equals 5 root 2. And so now let's look at this part, cotangent DBE, cotangent CBE, and cotangent DBC. So I've just put out the same angle values here, and we also have to add that BD, this much, is equal to 5 root 2, right? Right, so that's 5 root 2, and then now let's focus on the cotangent part. Cotangent DBE, cotangent CBE, and cotangent DBC, they form an arithmetic progression. So if we just write them out, that's cotangent DBE, cotangent of CBE, and cotangent of DBC, right? And if we look at these values, DBE, same thing we did before, that's DBE, that's A, right? So that's just cotangent of A, cotangent of A, right? But then now we know that A is equal to 45 degrees, which is 4 over pi, which is pi over 4, right? So this is cotangent pi over 4, and then this is cotangent CBE, and CBE, that's also going to be A minus B, right? So that's cotangent of A minus B, and since A is pi over 4, that's pi over 4 minus B, right? And then lastly, we have cotangent DBC, which is DBC, right? So that's just this angle, so that's angle of B, right? So that's cotangent B. So that's cotangent of B, right? And so since we know that cotangent pi over 4 is 1 over tangent pi over 4, and tangent pi over 4, that's just 1, right? So this is 1 over 1, which is 1. So cotangent pi over 4, this is just 1. So we have 1 cotangent pi over 4 minus b and cotangent b, right? And so since this is an arithmetic progression, like we said before, then that will mean that 2 times this one, 2 times cotangent pi over 4, so 2 times the cotangent of pi over 4 minus b, this is going to be equal to 1 plus cotangent of b, 1 plus cotangent of b, right? And so if we change all the cotangent into tangent, that will be that will be just 2 over tangent of pi over 4 minus b, and this is going to be equal to 1 plus 1 over tangent of b, right? 1 plus 1 over tangent of b. And so now if we can expand that tangent like the one we did before, then that's going to be 2 over, so that's going to be 2 over, and then that's going to be tangent of pi over 4 minus tangent of b over, and this is the bigger, right, and over 1 plus tangent pi over 4 times tangent b, right? And since we know that these are those are 1, right, so we can just cross them out and make 1. So that's just going to be tangent b, and this is going to be 1 minus tangent b, right? And so this is going to be equal to this, which is 1 plus tangent b, 1 plus tangent b over tangent b, right? And so if we put this one up there, that's going to be 2 times 1 plus tangent b over 1 minus tangent b, right? And now we can see that these two are going to cancel, right? So let's move up. This is going to be equal to 2 over 1 minus tangent b is equal to 1 over tangent b. So if we cross multiply, 2 tangent b is equal to 1 minus tangent b. So 3 tangent b is equal to 1. Tangent b is equal to 1 over 3, right? So tangent b is equal to 1 over 3. And so tangent b, that's going to be BD under CD, right? So that means that DC over BD is going to be 1 over 3. And since we know that BD is equal to 5 root 2, as we got before in here, BD is equal to 5 root 2, right? So this is equal to DC over 5 root 2. 5 root 2, right? So DC is equal to 5 root 2 over 3. And then we want the area of ABC. We want the area of triangle ABC. And if you see the area of ABC, this is going to be equal to the base, which is AC, times 1, yeah, so that's going to be 1/2 times the base, 1/2 times the base AC times the height BD, right? Height BD. But then if you see DC, this is exactly 1/2 of AC because these are both angle of B, right? So this is equal to this 1/2 of AC is DC. So this is DC times BD. This is equal to 5√2 over 3 times BD, which is 5√2. So this is equal to 5 times 5 times 2 over 3, and that's going to be 50 over 3, right? So this is the answer. The answer is 50 over 3, and so if we go all the way back, the answer is 50 over 3, which is B. Last problem, number 25. Given that 2 to the 2004th power is a 604-digit number whose first digit is 1, how many elements of the set S equals 2 to the 0th power, 1th power, 2nd power, all the way to 2003rd power have a first digit of 4? First, what we need to know is that given n digits, there must be 1 power of 2, so exactly 1 power of 2 with n digits that has a first digit of 1. This is true because for powers of 2 to the nth power, when going from the n-1 digit, n-1 digits to n digits, right? To n digits. This is just increasing 1 digit. Then we have to do multiply by 2, right? And any digit, so any number from 1 to 9 multiplied by 2, if that increases a digit, the next first digit becomes 2, what we get. And this is because for powers of 2, so for powers of 2, right? When we are going from the n-1 digit, so from the n-1 digit to the n digit, we have to multiply it by 2. The first n-digit power of 2 and n-digit power of 2 must start with 1, because like think about it. If we have a power of 2, let's say it's I don't know, 256, then this is multiplied by 2, and that gives us 512, right? And then this multiplied by 2, this gives us 1024. We increased by 1 digit, so it increased from 3 digits to 4 digits. The first digit is always 1, because if we always go from n-1 digit to n digit number, right? Then we will always be multiplying by 2, right? And so if we ended with like 7 something here, then the next times 2, that will always start with 1, whether this is 5 times 2 or 6 times 2 or 7 times 2 or 8 times 2 or 9 times 2, the nth digit will always start with 1. And so that's what it means by the first n digit power of 2 must always start with 1. This is the only this is the only possible n digit of 2 that starts with 1, because after this first power, there can be no other n-digit powers of 2 that starts with 1. Because if we just have something that starts with 1 already, then if we just take this and multiply 2, then that will become 2 something something or 3 something something, right? So that's going to be the only multiple of so that's going to be the only power of 2 that starts with 1, that has n digits, right? And now let's get into the actual thing. 2 to the 4th power, this is a 604-digit number, right? So this means that the 604-digit number, with first digit n, this is going to be 2 to the 2004th power, right? So this means from 2 to the 0th power all the way to 2 to the 2004th power, right? So counting just powers of 2, we are going to have 603 numbers, so 603 powers of 2 that start with 1. Right? And the next, if we have 603 powers that start with 1, then starting with 1 multiplied by 2, this gives us starting with 2 or 3, right? Because if it's 10 to 14, multiply that by 2, that will just give us first of 2, and if it's 15 to 19, that will give us a first digit of 3, right? And so if we do that, then that will just be the same number of powers. So that's also going to be 603 powers that start with 2 and 3. And if we multiply this by 2 yet again, our possible starting digits, this is going to be 4, 5, 6, or 7, right? Because it's 4 if it's like 21 times 2, but then if it's like 35, if it's like 37 times 2, then that's gonna start with 7, right? And so this is also the same number of powers, so that's all just gonna be 603 powers, right? And if we add these all up, if we add them all up, then this is going to be equal to 3 times 603. So this is going to be 1809 powers that start with 1, 2, 3, 4, 5, 6, or 7, right? 6 or 7, right? Because because they're all going to start with 1, 2, 3, 4, 5, 6, 7. So there are 1,809 powers that start with these numbers, and so the powers that don't start with these numbers, right? So the powers that start with 8 or 9, right? This is not starting with this. So we have 2004 powers, but we used 1809 of them. So this is 2003 minus 1809 is equal to 195. So this is from 2 to the 0th power to 2004th power. So this is from 0 to 2003, right? Because 2004 is already 604 digit number. So this is 2004 possible powers minus, and then we have 1,809. So minus 1809. So this is going to be equal to 195. This is the number of powers that start with 8 or 9. Let's do that in a different color. So this is the number of powers that start with 8 or 9, right? And then see, if something starts with 8 or 9, then the power before that that is 100% gonna start with 4, because starting with 8 means that the before value start with 4, and starting with 9 also means that the before value start with 4, and so that means the number of powers that start with 8 or 9 is equal to the numbers that start with 4. So this is equal to 195, right? So this is the answer. The answer is 195, which is B. So that was it for the AMC 12B from the year 2004, and thank you for watching.